In this video, I will show the solutions to question 10 from 2017 paper 1 additional mathematics. So the first part of this question reads, find the vector equation of the perpendicular bisector of the line joining the points -3, -9 and 11,5. That is part A. Part B, the position vector of P, Q, and R are 3i minus 2j, ni plus j and 2i minus aj respectively. Find the value of n for which P, Q, and R are collinear. I'm going to start with the first part of the question, 10a. Finding the vector equation of the perpendicular bisector of the line joining the points -3, -5 and 11,9. So the points that are in this equation have not been given letters, so I'll put letters on the points given. So I'll start with the first one. So the first one, I'll put it as A with a -3, -5. Then B, 11,9. So 11,9. So now, if these are the denotations for the points, so we want first of all to get the perpendicular bisector of this line and then find the vector equation of the line. So to help us solve this question, I'll draw a very simple sketch that is just going to show very little information. I'm going to draw the line joining A to B. Now this line, I'll draw it like this, slanted from down here to up there. So I'll say this is A. Why am I putting A this side? If you've seen -3, -5, this is on the negative x-axis and negative y-axis. If you imagine that this point is on the xy plane, so -3, -5. Then B is 11,9, so meaning B is on the positive x-axis and y-axis, so 11,9. So now, if these are the 2 points, then it means that we have to come up with the bisector of these 2 points. We have to come up with a line that is cutting these 2 points halfway. So coming up with a line that is cutting this line AB into 2 equal parts, let's just estimate somewhere here, just even somewhere there. So if this is the line that is cutting this line AB into 2 equal parts, then this means it's a perpendicular bisector. So a perpendicular bisector, one thing is it's a bisector because it's cutting the line AB into 2 equal parts and perpendicular, forming up a 90 degree, at the point of intersection. Now at this point we're going to say it's the midpoint. This point where the line AB is meeting with this line we've drawn, which is the perpendicular bisector, we're going to say there's a point M. Usually point M means the midpoint of 2 points, So if we say that is M, then we can also introduce another point somewhere here, say point C. Now this point, we're not going to find the coordinates of that point, but it's just there for calculation purposes. Yeah, just to make our work easy. So now, after coming up with this simple sketch, what do we get first? So let's get the direction vector of the line AB. So the direction vector will just involve the points A, B. So the points AB, we can change the points AB as the column vectors. So for example, the point A will just change to OA as a column vector, and it will just have the same values here: x negative 3, y negative 5. So you start with the value of x negative 3, then the value of y negative 5, then comma. B will be OB as a column vector with 11 and 9 there. So once we come up with the points OA, OB, then it means we can get the direction vector of the line AB. So what is the direction vector of the line AB? So AB vector is equal to, it's a simple subtraction of OB minus OA. So OB vector minus OA vector. Now what is AB vector? So if you subtract, we'll start with 11, 9, subtracting negative 3 and negative 5. What does this subtraction give us? So AB vector is equal to 11 minus negative 3. 11 minus negative 3, there's addition here. Negative, negative, that's positive. So 11 minus negative 3 gives 14. Gives 14. Then coming to this one, 9 minus negative 5, that's also addition because negative, negative gives us positive. So 9 plus 5 also gives us 14. So we're getting 14 on the x component and 14 on the y component. Now there's a connection between the direction vector and the gradient of the line. The direction vector and the gradient of the line. So I'll try and change this direction vector to gradient. Okay, so this is going to be the denotation for gradient is m, so I'll write capital M and then say AB. So what this means is this is the gradient for the line AB. So what is the gradient for the line AB? So if you've seen, this is the x component and this is the y component. So this means you are going to write 14 over 14. If you simplify 14 into 14, that gives a 1. So this means we're getting a 1. Or maybe let's write it like this: 14 to 14, 1, 14 to 14, 1. So meaning 1 over 1. So the x component is 1 here, and the y component is also 1, which just basically gives us 1 anyway. But we'll maintain it this way. Due to the nature of the question, I'll leave it at that. So the value of gradient of the line AB is 1, but I'll show it as 1 on top and 1 below. So meaning y component is 1 and the x component is 1 for this gradient. Then let's get the midpoint M. Let's get the midpoint M. To get the midpoint M, I'll show it from this side. So midpoint M, the formula is just a simple one: x1 plus x2 over 2, comma, y1 plus y2 over 2. Then M. So we can give the denotations for these points. This one we're going to say x1, y1, then this x2, then this y2. So x2 and x1 will add, so meaning negative 3 plus 11, so this over 2, comma, 9 and negative 5 will add, so negative 5 plus 9 over 2. So what is M giving us? So M, when you add negative 3 plus 11, that gives positive 8. So over 2, comma, negative 5 plus 9, that is 4. So 4 over 2. Then M is 2 into 8, that's a 4. 2 into 4, that's 2. So this is the point M. This is the point M. Expressing M as a vector, is going to be O to M is equal to, you start with a value of x, which is 4, and then value of y. So meaning that as a column vector, OM is going to be 4, 2. Then now, the relationship that is there, let's get back to the situation of gradient. If the gradient of this line is 1, positive 1, then what will be the gradient of this line? We're just going to apply this simple working. The relationship between these two is that since these two are perpendicular, then this means that the gradient of the line AB multiplied by the gradient of the line MC, this gives -1. This relationship is the relationship that exists between lines that are perpendicular. The gradient of this one times the gradient of this one is equal to -1. Now we've got the gradient of AB, which is 1 from this combination. 1 into 1 is 1. So meaning that here we just put a 1. Now what is 1 times M, meaning gradient of MC, line MC. The 1 can just multiply with the MC to just give M, gradient of the line MC equal to -1. Okay, so this means that if the gradient of the line AB is 1, then the gradient of this line MC is -1. Now let's do this in terms of components. Putting this into components, this means that the y-axis, the change in y is negative and the change in x is positive. So we can, just using -1, we can do this. So M, gradient of the line MC is going to be, so on top, this means that we're going to have -1 on top, and below we're going to have +1. So the y component is a -1. The x component is a positive. So as a direction vector, MC is going to have the following components. Now I just want to take, before I write this one, I just want to take you back to how I did the change from direction vector to gradient. So if you've seen here, AB is equal to, we found 14 and 14 here. So meaning the x component is 14, the y component is 14. Then when writing the gradient of the line AB, we got the value of y, we put it on top, 14, and the value of x, 14 below, thereby giving us 1, 1. And the gradient we got is a 1. But we said we're going to show it as components. So meaning on y we've got 1 and on x we've got 1. So it's same applies to this one. So for us to convert from gradient to direction vector, we'll just do the same. We'll write it in terms of component. So the x component, we'll start with the x component, meaning it will be up here. Then the y component, which is a -1, will be down here. So this is MC vector with the component x as positive and y as negative. So after getting MC vector equal to 1, -1, we now have to work out the last part of this question, which is coming up with the vector equation of this perpendicular bisector. So to do that, I'm going to put a point along the line MC. Let me just say this is point R. So if we put a point R is going to help us come up with the vector equation of a straight line. Now imagine that all these points, point R and point M, are connected to the origin. So this means that to M is 4, 2. Then it also means that O to R is connected from the origin, so it will be OR vector. Now OR vector, we're not going to find OR vector. In short, we're just going to show that OR vector is the same as the R vector using a single letter. So this means that we're going to use this OR vector, which is equal to R, to find the vector equation of a straight line. So this is going to go like this. So at some point I'll use this. I'll also use OM vector and also MC. So this means that coming up with the vector equation of the line, we'll just say OR vector is equal to, so if O is connected to R, then it means O to R, then OM. To find OR, we say OR is equal to OM/MR. So OR is equal to OM vector, then plus MR vector. But we don't know MR vector. What is MR vector? MR vector is part of the vector MC. So we're going to say MR vector, it's the vector. So MR vector is part of the vector MC, or MR vector lies on MC vector. For example, it can be expressed as 1/2 of MC or 1/3 of MC. Therefore, MR vector can be expressed as TMC vector. Meaning that value that we don't know, we're going to let it as T. So MR vector is equal to T of MC. T of MC vector. This means that MR is part of the line MC. So it's just taking a fraction of the line MC. So MR is TMC. So substituting this into this function will give us OR vector equal to OM vector plus TMC vector. OR vector is represented by R from what we did here. So meaning here, instead of putting OR, we're going to say R vector equal to, on OM, we got 4, 2. So we're going to put 4, 2 here. Then plus T, which is just a scalar because of the arrangement on the line MC with respect to R here. Then MC is this direction vector that we got. So this will give us 1, -1, close. So this here is the vector equation of the line perpendicular to the line AB. So if you want, you can put it in terms of components, which will mean that this will be R vector equal to, for 4 will be in terms of I, then plus 2j, then plus T, open bracket, I minus j. Okay, so we can even leave it at this. So this is our solution in terms of I and j. This is the vector equation of the line perpendicular to the line AB. So that is the solution for this question. So we're now going to work out part B, 10B. Now on part B, what we have is the position vectors P, Q, and R, and P has 3i minus 2j, Q has ni plus j, and R has 2i minus 8j. So the instruction on this question is find the value of n for which p, q, and r are collinear. So first of all, let's show that these points are position vectors. So p, q, r. So position vector p will start from O. So OP is equal to 3I minus 2j. Then OQ, position vector, OQ is NI plus j. Then we also have been given R, so we'll say OR vector is equal to 2I minus 8j. So these are the position vectors of the 3 points P, Q, and R. Now, finding the value of n, what we just have to understand is the word collinear for these points. So collinear, if they've given the word collinear for vectors, what does that mean? So this means that these 3 points have the same direction vector. So these 3 points have the same direction vector. So the direction vector for the points P, Q, and R is the same. In another way, if you're just looking at them as points, collinear means that they are falling in the same line and they have the same gradient. That is, if they are just points. So they have the same gradient and they are in the same line. So getting back to the concept of collinear vectors, what we're just going to write is this relationship. So P Q vector is equal to K Q R vector. This relationship that we've written is the relationship for collinear vectors. So meaning these vectors are related and they've been connected by the factor K. So what the factor K just means is maybe PQ may be longer than QR, or QR may be longer than PQ. So factor K is just size. It just has to do with size. But for direction, these vectors have the same direction. So PQ has the same direction as the QR. So they've got the same direction vector. So using this relationship for collinear vectors, then this means that let's now work out PQ. What is PQ? So just using the left side, I'll show PQ. How do you get PQ? So PQ, you get PQ by subtracting OQ vector minus OP vector. Then on the right side, so we maintain K. How do we get the vector QR? It's just by subtracting OR vector minus OQ vector. So the subtraction of OR vector and OQ gives the QR vector. So on the left side, what are we getting here? So we're going to show the subtraction in terms of components. So we start with the n. So I will show this in terms of column vectors. So n will subtract with 3. So n is x, and here 3 is x on OP. So minus 3. Then OQ as y component here as 1, and this OP y component is negative 2. So this means 1 from there, subtract negative 2. So all this equal to K, keep K. Then even this side we subtract OR vector minus OQ. So OR, we start with the x component 2, subtracting with n, which is the x component here. And then y component negative 8, subtracting with the 1. So this is our subtraction for the vectors QR, which is on the right side, and PQ on the left side. So now n minus 3 will not subtract, so we just maintain it like this, n minus 3, then equal to k. So we work out the x component, so 2 minus 1. So these are just like this because they can't subtract, they are unlike terms. But below here we can subtract here 1 minus negative 2. This is negative times negative positive, so 1 plus 2, that gives a 3 here. Then on this part, the y component, negative 8 minus 1, that gives a negative 9. So from what we've gotten here, we can come up with the equations. The first one will be n minus 3 is equal to k there, then open bracket 2 minus n. So this is in relation to the x component. So x component, so this is equation 1. Then equation 2 is 3 equal to k times 9 there. So 3 equal to k times 9. Equation 2. So if this is our equation 1, then this is our equation 2, then let's work out k using equation 2. So from equation 2 we can work out k just by doing this. So k is going to multiply with the negative 9, so this means 3 is equal to k times negative 9. This gives us negative 9k, and division of negative 9 gives negative 9 to negative 9, 1 times k is k, so we can even bring this k this side. Then here we can just simplify. 3 into 3, 1, 3 into negative 9 is negative 3, so meaning we got 1 over negative 3 as k. So our k is 1 over negative 3. Let's use equation 1, and we're going to substitute k equal to 1 over negative 3 into equation 1. So for that, we just show it this side. So we say from equation 1, n minus 3 is equal to k. So on k we'll put negative 1 over 3. So this is multiplying with 2 minus n. Now if this is a fraction, then it means that 3 below here can multiply with what we have on the left side here. So 3 times n minus 3. So 3 times n gives us 3n. 3 times negative 3 gives us negative 9, equal to, here we've got a negative 1. So negative 1 will multiply with the 2, so giving us negative 2. The negative 1 will multiply with negative n, negative, positive n. Collect like terms. So 3n minus n is equal to, we maintain negative 2, then we move 9, this side will be plus 9. The difference here gives 2n equal to negative 2 plus 9 gives 7 positive. So divide by 2, n is equal to 7 divided by 2, which is just 7 over 2 as a fraction. 7 over 2 is the solution to this question as n. So thank you so much. I hope you've enjoyed this video. Look out for more content in additional mathematics in my next videos. And if you have not yet subscribed, please subscribe so that you can get all the latest updates about the information that is posted on this channel. So thank you so much.